without further ado, I welcome Professor Manish Parashar, who is there, to do his presentation. As I say yesterday, and I don't do bios, we are all friends. You want to know about him. Everyone here is beyond important, but it's something that we tell to our spouses, but we don't believe it. All right, thank you.
Good morning, everybody, and thank you, Nicholas, for the workshop and for inviting me. It's always a pleasure to be here and enjoy this conversation. So I'm going to talk about a project that we've been working on for a couple of years now called the National Data Platform. It's led by Ilkay. We'll tell you more about it tomorrow. So I want to give you an overview as to why we're doing it and why it is important. And then I'll focus in on a couple of engineering efforts we've been doing in the last year or so, just to introduce them to you, but also get your inputs on whether this makes any sense or not. The motivation here is clear, right? I think I don't have to belabor the point here, right? AI is permeating everything. It is becoming really an engine for doing science. Is changing the way we do science, complementing our traditional ways of doing science, and it has, we have this vision of tremendous impact that AI can make on science, on society, and we touched on this yesterday. That there are also concerns, whether it's environmental, whether it is from a responsible perspective, whether it is from a security perspective, a fairness perspective, an equity perspective. There are definitely issues we should be concerned about. And so we have to use AI in a responsible way. Clearly, those documents are dated, right? I should have put the Genesis mission slide in there. And if you want to do AI responsibly, we really need to tackle it completely. And we know that responsible AI, to do it, we need to make sure we have data that is responsibly collected, used. We understand the data, it's trustworthy, right? So this is generated by ChatGPT. It's interesting to see that they put the Star Trek data in there, and I didn't explicitly ask for that. All right, so I'm sure there's a reason for that. So let me dig a little deeper into why data is important, right? So a couple of points here. This is a chart from late summer. This is from Big Data Wire. This is the Gartner hype cycle, but it is focused on data. And I don't know if you can read it, but up there is AI ready data. The other things, AI agents is up there. Sovereign AI is up there that we talked about yesterday. AI engineering, responsible AI, they're all up there at the peak of inflated expectations. Right? Clearly, it's important. People recognize that data is very, very important to AI. Right? But here's another example. This is a quote from David Baker. This is the 2024 Nobel Prize in Chemistry for computational protein design. And he was pretty explicit in his award lecture where he credited a lot what he was able to do to the Protein Data Bank, which is this open database of protein structures that allowed him to drive his research. And he said, look, I couldn't do what I did if I didn't have access to the data. So clearly, data is important. But there are two sides to it. So this is an interesting article. It came out in January in Science, right? They looked at 41 million papers, 2 million researchers, and looked at the patterns on how they use AI. And they came up with some very interesting insights, right? He says scientists adopting AI, they publish more, they receive more citations, and they also found that junior scientists using AI seem to have more effective career trajectories. They are really moving into leadership roles, getting promoted faster, right? So this is all good news, right? But they also had a second thing, right? They found that even though a lot of good things are happening to the researchers, it hasn't been good for the science itself. And the reason is that the locus of science exploration seems to have shrunk. You're looking at similar ideas, incremental research, compared to more traditional approaches. And the reason they found was this feedback loop, right? When you have popular problems, you create data sets, and then the research after that gravitates around those data sets that are there, that are ready for use within AI workflows, right? And that means that you're really doing research where you're looking for things where the light is on, right under the lamppost, because you have the data there, so you start doing more exploration there, right? And so clearly, right, if you really want to get this broader benefit of AI for science, you have to broaden the type of data sets you have and access to these data sets, right? You need to be able to make sure the data is abundant, it's usable, it's useful, and it's actually used, right? If you want to, otherwise, we'll keep on looking for things in this no spectrum where we have these limited, right? And I think to expand that further, the real potential of AI is being able to look across very diverse and heterogeneous data sets and finding these correlations, these patterns, right? And if you have these siloed data sets, you're limited to what you can actually do with science. So we clearly have to, it's not that we lack data. There's a lot of data out there. Problem is it's very hard to use. So let's try to dig a little deeper as to what these data challenges are, right? We clearly have a lot of siloed data ecosystem. We have a lot of data across all the fields in varying levels of quality, but you have the data, and you're generating more data. You're instrumenting more instrumentation, more data collection, more data sources, both in the sciences, but also in the humanities, in the social sciences. You're clearly collecting a lot of data, right? But these tend to be very siloed and very domain-specific. It's really hard to, both from a mechanics perspective, but also from a science perspective, be able to cut across these different data sets. Inconsistent data services, again, part of the siloed problems. It's very hard to deploy and use these data platforms, right? They're customized for a certain domain. They're customized for a certain discipline, for a certain user community. And then often these data sets tend to be very far away from the computing and the models are, right? So connecting them as part of the ecosystem or as a workflow is really hard, right? So there are clearly a lot of infrastructure challenges, but there are also a lot of challenges from the user's perspective, right? If I'm working in a certain field, I know the data sets, I know where to find them. But if I go beyond that, I don't even know what the data sets are, right? I don't have the ability to use data sets across these different fields. Often access to the data sets is really, really hard. And part of the reason is that the computing tends to be far away. You have these humongous data sets that you have to download and then clean up and then integrate your workflow and then use, right? So even if you knew they were there and were able to use them and access them, right, using them in the workflows, this thing. And often you're using data sets in your discipline, you know who generated a data set, you have a good understanding. But you start looking at data sets across disciplines, you don't know if that data set is fit for use, right? Is it the right data set from the questions that I want to answer? And how do I ascertain that, right? And given this whole proliferation of data sources, right, it might make sense to use data sets, but if I can't assess that, it's hard. And of course, then how do I associate with communities so that I can figure out what is relevant and how to use it, right? So we have been focusing a lot on open data. We have infrastructure, open data, right? But I think you have to move beyond it and make sure the data is useful, it's usable, and it's actually used, right? And that requires a lot more of the infrastructure in addressing these challenges, right? It's not enough to create a repository and make it public, right? You have to go much beyond it, right? And that is, in a nutshell, the problem that the National Data Platform is trying to address, right? This is about a 2.5-year-old project. As I mentioned, it's being led by Ilkay out of UCSD, University of California, San Diego. And it's really trying to create a federated data ecosystem that allows you to take data sets that are already out there and make them useful, usable and actually used, right? And build on existing infrastructure. So it's not a new infrastructure, it's a federation of services and methods and expertise that can take existing data sets and make them discoverable, provide the usage and the services to integrate them in your workflows, providing governance mechanisms, providing trust mechanisms in there as part of this. Is a URL, and you can go in and look at some of the things that are out there. But to summarize, right, what NDP can help you do is to facilitate data cataloging, to make data fair and used at scale, provide collaborative workspaces so you can come together around the data sets and create workflows, create projects. You can deploy services that then execute near the data. So downloading data is not the only modality you have to use the data. It builds on existing infrastructure in cloud, so you don't have to really create a new infrastructure. If I have a cloud credit, or I have an account on AWS, or I have an allocation on the National Supercomputing Center, you can say, run this workflow with this data on this resource that I already have. So bring your own resource is integral to it. It focuses on using data across disciplines, the integration of data sets rather than just using a single data set, and building the capabilities around data, the ability to use data is a big part of this project. I'm not going to go into a lot of technical details about the project, and we're happy to have that conversation. I'll give you, at a very high level, a few slides overview, and I wanted to then dig on one effort or two efforts that we've been looking at recently. So this is sort of a high-level architecture. There is a central hub which has a catalog where you can find different data sets, models, services, right? You have workspaces that support education, data challenges, and research. And you can, in a workspace, you can bring in the models you want to use, the data, right? This is like an extended Jupyter notebook, if you will, where you can bring these data sets and work on it. But on the other side of it, you have a federation of data NDP endpoints. And what these are standard, lightweight software stacks that can be stood up very easily in front of a data source or a community. And what it does, it makes that data set, exposes it into this federation along with the services and metadata that you need to use that data, right? So if I have a data set and I have different kinds of services that might help me use that data set integrated in my workflow, you can deploy it on these endpoints and make it discoverable, right? And so that allows you to then deploy new services or make services that really make this data set usable. On the other side, if there's a community that uses multiple data sets and has a bunch of services that integrate those data sets or do analytics on it, they can set up an endpoint and expose that as part of the community, and these federate to become the hub. And within each endpoint, you have the standard catalog services, but you can deploy your own custom services. And this is one example that I'll go through very quickly of a custom service stack that was built and then integrates into this, right? So that if I have a data set that needs special kind of services, I can deploy them and share it with the community, and they run on this endpoint close to the data from a access perspective. And just to talk about it, for example, we deployed as part of the value-added services, staging service, which allows you to work on multiple data streams, high throughput data streams that are coming in, to be able to do filtering, to create derived streams, to do server-side transformation of data, and to be able to really process that data in motion, right? And this is, this is a staging service, but we also have a streaming service that does it on stream. The staging service allows me to deploy data close to the source and do transformations of data close to it. And this then allows us to do interesting workflows like this, right? And I talked about this, I think, previously as well, but this is a project we've been working on for some time. I think it builds on the insight that, if you want to be able to effectively do early earthquake detection, you need to combine multiple types of data sets. You want the traditional seismic data sources coming in, but if I can augment it with GPS streams, I can detect the earthquake using the S waves and P waves much earlier. And this requires doing analytics that combine these two different data sources in an effective way. And that can be quite challenging because they typically come from different sources. There are different formats. This is coming at 1 hertz streams, and you might have thousands and thousands of these streams coming in. And then you have the seismic data that are typically coming from these ground seismic stations, and how do you correlate and integrate that? And so that's one of the use cases we have been working on, right? We're working with Earthquake, which has about 2,500 1 hertz streams that are coming in from GPS. And what you're trying to do is detect XYZ displacements, and then integrate those, when you detect those displacements, integrate that with the seismic measurements to be able to localize where the P waves is and give an early warning there. So we're working with a couple of projects, the Cascadia project for the Pacific Northwest in the US, and the EarthScope to do this detection, right? And so what we do is we use an endpoint which is running on AWS. These streams are coming in from GNSS, the Global Navigation Satellite System. Since this is really high volume data, we want to very quickly in the cloud detect when the displacements in a region of interest are relevant to me, right? When the XYZ displacement in a region of interest is interesting, I immediately create a derived stream using this, right? And so this derived stream then allows me to basically say, okay, this is interesting. So I don't have to monitor all the data all the time. In real time, I can quickly derive them, I can visualize them, I can integrate them, and I can trigger workflows that can then start triggering other downstream activity when that derives, when the displacements meet the constraints that I'm looking for, right? And the endpoint actually supports this entire workflow, right? It takes seismic data coming from stationary and integrates it into when I detect that the streaming services are interesting. Right, so this is, again, I can go into more detail, but this is one example of a type of workflow and NDP supports. Here's another one, right? This is air quality, which is close to my heart because, as some of you know, due to inversion, Salt Lake City has a huge problem, and we've been trying to address it with the state. We've actually instrumented a lot of our bus systems, our public railway system, the buildings, to create early warning, right, for schools, to say when do you have recess for the kids, elderly people, right? So there's a lot of people impacted, and like a few weeks back, the inversion was so bad that you really couldn't go out because of the air quality, right? So how do you detect this? Now the problem is the data we have is sparse, and there's a lot of it, and it has to be cleaned up to be able to detect and make predictions about what time of the day is it okay to go outside, or when I schedule activities, can I give that guidance? And so what we do here is to use course predictions that can come from a large language model such as Aurora, which detects this. But this doesn't give you the resolution you need, but can tell you at a broad level what the patterns are, right? So we can use that to actually detect where to actually sense and where to create that, to assimilate data and do predictions, because that's where we know for the next 6 hours, that's where we expect air quality to be bad. So it allows us to be more focused on what we do with that data. Again, you have two data sources. You get the data coming in from the federal agencies. We feed it to this LLM that gives us a course level of prediction as to where it's interesting. We use that to adaptively sense our air quality sensors. We feed it to the computational models, and we can issue warnings. Again, this is the idea of combining data sets, right? So with that was sort of an overview. In this talk, I wanted to focus on two issues that we are trying to address that we see as real problems here. The first one is, once you start giving people the ability to use different type of data set, right, the problem now becomes the abundance of data that you have. So how do you find out what data is fit for purpose? What data should I actually use to answer the questions? I know in my area what the data sets are, but if I'm going to look at data sets from another area, I don't have that understanding. And the second thing was, can we reduce the barrier to discovery, right, by using some of the agentic techniques that are getting popular, right? So these are interesting engineering problems that we've been trying to address. So let me look a little deeper in the first, right? And here the idea is that if I look at trust in data, there are at least 3 dimensions here, right? The first one is understanding what the data is. What is the provenance of the data? How was it collected? Where was it collected, right? How is the data governed? Who can change it? What happens, right? So these are very important to get trust. But there's a third dimension out here which looks at who's using the data, right? Is it being used to answer the questions I want to answer? Who is trying to use the data to answer the question? What is the impact of the research they do using that data sets? Right? Are they using it with other data sets? So how can I look at the data and figure out whether it's fit for use for me? Right? So if I go and search a catalog, I'll find tens or hundreds of data sets. And how do I figure out that this is the right data set for me? So we've been trying to tackle this by extending the search capability in NDP, which already has a bunch of different search capabilities, but we said, okay, let's add this ability to get some contextual insights from a use perspective, right? And so let me dig a little deeper about what we are trying to do here, right? So this is, when a data set comes in, what we do is we try to use an LLM to characterize that data set in terms of keywords that describe the data sets, right? In terms of, this is a climate data set, it's using, it's trying to measure these type of things in this region, but are there some keywords that flag that? And we might have the owner of the data be part of that process, okay? And once we have that, right, we can then take those keywords and go into existing publication corpuses, OpenAlex, Dimensions, PubMed, and find relevant publications that align with those keywords, right? And then, so we have, we get a corpus of pretty large because these are common keywords, but then we can go, and again, using some of these large language models, we actually do a deep dive into the full text of the data set, right? And so what that allows me to do is to find the context within that paper or that publication. It could be funding, it could be patents, right? It finds how that data set is used, okay? And what is the context, right? It also allows me to find, are there other data sets that are mentioned in the same paper, and how are they used? It might find out what tools are being used with that data set. So we come up with a rich metadata knowledge graph that we create, and then we expose that to the user so they can navigate it, right? And so you get things like this. You get a portal where you can find what the data set is, right? And a lot more information. Let me give you some more insights. And this is actually, you can go now to nationaldataplatform.org and play with this, right? Right. So for example, you can say, I'm interested in medical imaging, right? And it gives you a bunch of different data sets, and one data set that's pretty common from the NIH is the MIDRIC data set. It's very popular with medical imaging, right? And so in the data sets where we have run this algorithm, you get a little bit of a button that says insights, right? And so you can dig deeper into that, and it gives you information. It says, here's the data set. It's being used by 1.47K researchers. There are 402 publications with this. These are cited by 6.26 thousand and so on, right? So it gives you some idea of who's using the data set, and then you can go and say, okay, who are the top researchers, and how are they using the data set? What are the top institutions using the data set, and how many publications? So now I start understanding who's using it. What is the impact of the research using this data set, right? If it's relevant to the questions that I'm asking, maybe this data set is interesting to me. I can go deeper. I can say data set joins, right? Now here it tells me that with this data set, users are also using this other data set. And I have evidence as to how they're using it, and I have a confidence that they were used for the same workflow, right? Now that allows me to find relevant data sets that might be interesting to answer my questions, right? I can also do other things. I can say, okay, what codes are they using for this data set? And what are the repositories, right? So I can filter by language. Okay, they're using this kind of a code base to do the analytics that they mentioned. And so on, right? You can find out who are the most active researchers, how was this used over time, and so on, right? Here is what are the institutions, what are they used by different areas, right? So there's a lot of rich metadata that you can get out of this, which helps you then get some confidence in the data, right? Now we're actually building another layer on which we then sort of places. Right now this gets triggered when I say I want a medical imaging data set, right? But now we're looking at how you can change this and say, I'm studying the impact of air quality and respiratory illnesses. What data set should I use? And it can then go and do the same thing and tell you, okay, here's data set, here's why, here are the publications that are using it, here is the different things, right? So at this point, it's in beta mode. It's on nationaldataplatform.org, and we can use it, right? It is noisy. As you expect, it's built on LLMs, and it can be noisy. And so we are trying to clean it up. But love to get feedback on this. Does this make sense? How could we add to it? What are the other dimensions we can bring in? So I'd love to get some feedback on it. And I think Nicholas is standing up, so I should wrap up. So this is the other thing I want to talk about, was trying to add agentic interfaces on what we're trying to do. MCP, we talked about a little bit about it yesterday. Eva talked about it, so I won't go into details. But the idea is to reduce the overhead of creating these workflows, right? We have the typical steps in the workflow I showed you with the earthquake warning, and this is the code that goes into this in your Jupyter notebook, right? But with using a simple MCP, we can really reduce it into something like this. And so we clearly prototyped it. I have a good student, undergrad student, who did it, and I had a demo showing that, right? It's a movie here that shows basically you can do the same thing using this. Again, these are not perfect. They tend to be quite noisy, but at least it shows the potential that you can raise the abstraction on how you use the data, making it more usable. I will not go into this, but I will conclude. And again, I can show you the movie, but the idea is that you can say, show me all the sensors that show GPS data in the California region. Zoom in onto this sensor, stream the data for me. Let me know if the displacement has gone beyond a certain level. Plot this and feed it into my workflow. You can do things at that level, and that just makes it easier. Let me stop here and leave some time for questions. But I think this is really important that we make data that we already have more usable, more trustworthy, more fit for use for the science. Otherwise, we'll go back to the problem we are noticing, that we'll only gravitate to address problems that can be solved by the data sets that already exist, right? Look for keys under the lamppost because that's where the light is, right? But we need to think broader. And I think making this data, right, a lot of it is engineering solutions that make data that already exists more usable. But unless we do that, we will not realize the full promise here. Let me stop there and open it up for questions. Thank you.